Teddington Water Treatment Plant officially opened in 1971. Prior to this, water was treated at a now decommissioned treatment plant at Aberdeen Avenue in Maryborough. The water that is treated at Teddington Water Treatment Plant comes from Teddington Weir on the Tanana Creek. Teddington Treatment Plant features a series of sophisticated processes to remove contaminants and to disinfect water to improve the quality and taste. Teddington Water Treatment Plant treats 6 to 15 million litres of water per day and provides water to over 30,000 people in Maryborough and its surrounding suburbs. Water from the weir is transferred to the treatment plant using pumps. Water can be taken from 2 different depths in the weir. This is to optimise the quality of water taken. The water level in the weir influences the depths from which the water is taken. Before water is pumped into the treatment plant, coarse solids like weeds and debris are removed using screens located at the weir. The pH of the water at this stage is approximately 6.4, which means the water is slightly acidic. Lime is added into the pipework after the pumps, which increases the pH and alkalinity of the water, making it non-corrosive to metallic pipes and fittings. Water reaches the aerator via pipework from the pumps. In this process, air is added into the water to oxidize any manganese and iron that may be present. The process of oxidization combines the manganese and iron with oxygen, making it easier to remove them from the water in the later stages of the process. The pH of the water is adjusted again by adding carbon dioxide, which in turn lowers the pH. This improves the effectiveness of the next couple of stages in the treatment process. Water leaves the aerator and enters the contact tank, where the processes of coagulation and flocculation occur. Coagulation is the process of chemically combining the dissolved particles, such as the oxidized manganese and iron, in the water. This is done using the chemical aluminium chlorohydrate, or ACH. Flocculation takes place following coagulation and physically combines the particles into even larger particles called flocks. These flocks are much easier to see and remove from the water. From the contact tank, the water travels through pipework to the reactivators. In this pipework, polyelectrolyte is dosed into the water, which helps the flocks to bind together. This makes it much easier to remove the flocks from the water in the later stages of the process. There are 2 reactivators which are used to mix and settle the flocks. The center tank uses a stirrer which slowly mixes the water and grows the flocks. The flocks sink to the bottom of the reactivators and are then pumped to the sludge lagoons. The clear water rises and flows to the outer parts of the reactivators, which are called launders. The launders coarsely filter the clear water and channel it into pipes, making its way to the next stage of the process. The next stage of the process is filtration. There are 4 filters and 8 compartments in each filter. The filters are sand filters with different layers. The water is pushed through the filters using gravity, and that's why the filters are below ground level. Chlorine is dosed into the filters to further oxidize the manganese and iron, improving the water quality and taste. There's a system of drains under the filters to capture the clean water. Approximately every 3 days, each filter is backwashed or cleaned to remove captured solids. Clean water from the filters enters the clear water tanks. There are 2 clear water tanks on site that can hold a total of 1.5 million litres. Lime is dosed into the clear water tank to add alkalinity and increase the pH of the water to 7.8. This stabilizes the water and prevents corrosion of the pumps and pipes that transport the water to your homes. Gas chlorination is also used before the water leaves the site. This is to disinfect the water prior to transporting it to your homes via a network of pumps and pipes. The flocks from the reactivator and solids from the filters are pumped to the sludge lagoons. In the sludge lagoons, the solids or sludge settles and clear water from the top of the lagoons is discharged into a creek nearby that flows into Tanana Creek. The quality of the water is closely monitored and only discharged into the creek if it meets the requirements of the Environmental Authority. The Environmental Authority is a document issued by the Queensland State Government, which we must adhere to ensure we do not negatively impact the environment. The remaining sludge is left to dry naturally before eventually being removed to a location off-site for disposal. The site has its own laboratory, where testing is undertaken daily in accordance with the Australian Drinking Water Guidelines. Testing is undertaken to determine various characteristics of the water, such as aluminium, pH, chlorine, manganese, iron, turbidity, alkalinity, and colour. The network of pumps and pipes that transport the water to your homes is called the reticulation network. It consists of hundreds of kilometres of pipelines with pumps and storage reservoirs. Regular testing of the water quality is conducted throughout the network to monitor the health and safety of the water supplied.